Hi, in this video I am continuing with review number 2. We are now working on problems 14 through 17. Number 14 states the following. We're given a probability distribution and we have to compute the mean, variance, and standard deviation. For a discrete probability distribution, the mean is found by multiplying each outcome with each probability and then finding the sum of those products. So the mean is 5.2. So since this data represents the number of students who receive tutoring at the writing center, on average about 5.2 would be the answer. Now for the variance is found by squaring each x value, multiplying those squares with the corresponding probabilities, and then subtracting out the mean squared. So we take each value, square it, multiply it with the corresponding probability, find the sum of all those products, minus the mean, 5.2, squared. Performing the calculations, we end up with the variance is 1.5. Finally, standard deviation, we take the square root of 1.5 to get 1.22. Number 15, we're computing the expected value. It states the following. A lottery offers one $1,000 prize, two $500 prizes, and 10 $100 prizes. 1,000 tickets are sold at $10 each. Find the expectation. If a person buys one ticket, round to 2 decimals. So we construct the probability distribution. We have winnings and loss. The person loses $10. So we'll put a minus 10. Or negative 10. They could win 1,000, 500, 100. To win 1,000, there's one chance out of 1,000 tickets that are sold. For the $500, 2 chances out of 1,000 tickets. And for the $100, 10 chances out of 1,000. Next, we average out the winnings, so we're going to multiply each outcome with each probability, add the results, and then subtract out the loss. So 1,000 times 1 is 1,000 over 1,000, 500 times 2, 1,000 over 1,000, 100 times 10, 1,000 over 1,000. Add up these values, it's 3,000 divided by 1,000, which is 3. 3 minus 10 is negative 7. So on average, a person who plays this game is expected to lose around $7. Number 16 is a binomial distribution problem. It states the following. The chance that a student will pass a Physics 100 class is 69%. If 7 students are taking the class are selected, use the binomial distribution to answer the following questions. So n is 7. We're selecting 7 physics students. Probability of passing is 0 and 69 hundredths. We also need q, that's the probability of not passing. So 1 minus 0 and 69 hundredths is 0 and 31 hundredths. For part A, it's saying we want exactly 5 of them to pass. So we apply the binomial distribution formula. P of 5 is we have 7 students, we choose 5 to pass, times the chance of passing is 0 and 69 hundredths, raised to the 5th power because we want 5 to pass. Remember, there's 7 students. If 5 are passing, that means 2 are not passing. So times 31 hundredths raised to the 2nd power. Type that in the calculator to get the final result. It's 0 and 316 thousandths. For part B, it says at least 5 of them pass the class. So at least 5 means we want 5 to pass, 6 to pass, 7 to pass. We cannot go past 7 because that's the maximum number of students that are selected. So once again, we apply our formula. We have 7 choose 5 times 0.69 to the 5th power times 0.31 squared, and that's a value we computed in part A. For probability that 6 pass, we have 7 choose 6 times 0 and 69 hundredths to the 6th power times 0 and 31 hundredths, 7 minus 6 is to the 1 power. That's going to give us 0 and 234 thousandths. And then finally, we have the probability that all 7 pass. So 7 choose 7 times 0 and 69 hundredths to the 7th power times 0 and 31 hundredths to the 0 power. That's 0 and 74 thousandths. The last step is we add all 3 probabilities together. So the final answer is 0 and 624 thousandths. Using a similar process, we have at most 3 of them pass. So now we have to calculate the probability that 3, 2, 1, 0. We can't go past 0 because we have 7 people. There could be a chance that all 7 do not pass. That's what the 0 represents. Perform the calculations like we did previously. We can see that for each value below 3, the probability diminishes. Finally, we add up all the values together to get the final answer, 0 and 139 thousandths. Now, number 17 says the chance that a motorist in California operates a motorcycle is around 8.1%. If 450 motorists from California are selected, compute the mean, variance, and standard deviation of motorists who operate a motorcycle using the binomial distribution. So we need our key values. N is 240, the sample. The probability of riding a motorcycle is 0 and 81 thousandths. The probability of not riding a motorcycle is 1 minus 0 and 81 thousandths, which is 919 thousandths. The mean is NP, so 450 times 0 and 81 thousandths is 36.5. That's the mean number of motorists who ride a motorcycle. The variance is NPQ, so we take 450, 0 and 81 thousandths times 0 and 919 thousandths. Multiply it out to get 33.5. Finally, the standard deviation is the square root of 33.5, and that's 5.8. And so that concludes the problems on the review number 2. Thanks for watching the video.